Hi students, this is Professor Shrenik Shah. Today we are going to discuss a concept of Doppler effect of sound. Now, many a times you might have heard if a car or a vehicle is passing nearby you, when the vehicle is approaching you, the sound of that vehicle, the horn, or if it is an ambulance then it is a siren, or any kind of noise which that vehicle is making, that sound appears to intensify when it is approaching you, and it appears that the sound is decreasing or it is reducing in the strength when it is going away from you. Now this effect which you feel or which you listen is nothing but called as Doppler effect. Now to understand this in science with some formulas and some concepts, we need to understand 5 terminologies. The first one is N. N here stands for the original frequency of sound which is emitted by the source. Then there is N with suffix APP, that is standing for an apparent, that is apparent frequency. Now apparent frequency is something which you hear when there is a relative motion between the source and the observer. So that is not the original frequency, it might be something different from the original frequency which is emitted by the source. Now the third term is V, which stands for velocity of sound, which will always travel from source to observer. Then you have two terminologies, which is Vs and Vo, which stands for velocity of source and velocity of observer, because here we are going to deal with the relative motion between the two, the source and the observer. So now we need to deal with this in the terms of formula. So for that you need to understand how the formula is made. So let's go for that. So the formula is N apparent is equal to N times the relative velocity of sound with respect to something upon the relative velocity of sound with respect to something. Now this two part with respect to, one is going to be the source and the other is going to be the observer, definitely, right? So here we have observer in the numerator and source in the denominator. We will understand why observer is in the numerator and source in the denominator in a short span of time. But right now you can just remember this formula as it is, which means this is N times V plus or minus Vo upon V plus or minus Vs. Now this plus or minus sign, I hope you understand, it's basically dependent on what direction the source and the observer and the sound is moving. Accordingly we will have it. But if you talk in terms of vector thing, we can write it as N times V bar minus Vo bar and V bar minus Vs bar. Now I make this thing very clear that you cannot use this formula, write this formula in any book or in any paper, because practically the division of vector is not possible. But yes, if you can write this, now this formula, have no issues. You can use this formula as it is. So now to understand how this formula came up, let's take an example. Let's say there is a source and there is an observer. Both are moving towards each other with their respective speed Vs and Vo. Now we know the speed of the sound is V, which always travels from source to observer. So now if you check, we know for sure it is N apparent is N times V upon V plus minus something. Now we need to decide which one will be the source and which one will be the observer, right? Now if you remember, the observer was on the numerator. So let's first check whether the observer has to be in the numerator or not. If you check over here, the speed of sound is towards right and the speed of observer is towards left, which means they are going in the opposite direction. So if you practically go for V bar minus VO bar, you will get it as, for magnitude, it will be V minus negative VO, since they are in the opposite direction. So this means V plus VO. Now similarly, if I try it for V bar minus Vs bar in terms of magnitude, it will be V minus Vs only, because they are in the same direction. So now if you understand, we are sure that it is V plus VO and V minus Vs for this case. Now try and understand this. When the source and observer are moving towards each other, the frequency which you will hear will be more than the actual frequency of the source of sound, which means the N apparent should be greater than N, and that means this ratio should be greater than 1. Now I hope you understand that this is possible only if I put V plus VO in the numerator and V minus Vs in the denominator, because if I put the other way around, the numerator will become less than the denominator, and then this condition will never be satisfied. So basically, when the source and observer are moving towards each other, I can say this is the direct formula. But as I said, this is just for one case. We cannot remember for multiple formulas for multiple cases, right? So better to remember one formula, which is, as I repeat, N apparent is equal to N V bar minus VO bar magnitude form, V bar minus Vs bar magnitude form. This is the formula which you should remember for Doppler effect of sound. Thank you so much. I hope it helps you.